There we go. All right. So welcome to our April meeting of the the Brisbane Azure User Group. And normally you have Damien playing host tonight, but I think he's got a few sick people at home at the moment. So we're probably not going to have Damien, which means you're going to have to kind of put up with me tonight. So just as usual, we start off with a bit of a news roundup because the cloud moves fast and there's a lot of stuff that happens every month. I don't endeavor to cover everything. I just pick and choose a few highlights and bring that to attention. But we do have some references at the end of this deck for the blogs and stuff that we get that information from, so you can look that stuff up yourself. Big shout out to our sponsors, Codify. Definitely our main sponsor here, and also supplying our speakers tonight. So the Codify gave us a very generous budget, and that pays for things like the meetup subscription. And once we get back to live meetings, which is hopefully soon, they will be responsible for the pizza and beer as well, which is great. And that also means Microsoft too, which normally gives us the venue for hosting our events. So we're very, very grateful. Without the sponsors, this group wouldn't happen. So being a community user group, then we welcome people to get involved. As you can see, we've got the next couple of months sorted out with speakers, which is really good, but we've still got plenty of open spaces in the latter part of the year. And if anybody has something interesting they want to share and talk about with the group, you are very, very welcome to contact us. You can email this address here, or even just go through the meetup group if you want, and put a chat in there to volunteer. Mind you, it doesn't have to be a full presentation. Even if you want to just do a little short 10-minute TED Talk or something on something that you've done at your organization, we can definitely combine a few people together and have a night where we do something like that. So please let us know if you've got a topic to talk about. And for those of you who might be looking for a new adventure, I should point out that Deloitte and our team, the platform engineering team, is always interested in talking to people who are passionate about Azure or about cloud integration solutions. So if you've got any of these skills or interests that are on this slide, we would definitely like to hear from you. We're looking for people, obviously, who are technically excellent, but wholeheartedly passionate and aspirational about problem solving and creating integration solutions. So I think I probably left that QR code up here just long enough for you to snag that, but you can always reach out to me too if you're interested in an opportunity at Deloitte. So normally Damien puts together the updates, but I've had a crack at doing it this month because he's a bit occupied at the moment. So let's start by talking through some of the preview things that have come up in the last 30 days. So dynamic lineage extraction from Azure Purview. So it's good to know where your data is actually coming from. So conventional systems map lineage normally happens by parsing transformation scripts, which we call basically static code analysis. And that works pretty well in simple scenarios. For example, if you've got a SQL script that's used to produce a target table like customer sales, by combining or joining two tables called customer and sales, your static code analysis can usually map that data lineage pretty well. But in many real use cases, the data processing workloads can be quite complicated. The scripts might, for example, be wrapped in a stored procedure that is parameterized and uses dynamic SQL. There could be a decision tree with if then else statements in there executing different scripts at runtime. So trying to work out what's actually happened at runtime can be quite challenging. So with this new data extraction, it actually works by tapping into the instrumentation framework of the SQL engine and extracting the runtime log, so it can actually figure out what really happened. So this is really cool. The Purview scanners run several times a day to keep up the freshness of the dynamic lineage and the provenance from the Azure SQL databases. So that's preview. Another thing that we have in preview is private link support for APIM. So with this, with Azure API Management, you're now empowered to bring your Azure API Management instances to a virtual network using the same consistent experience that a lot of other PaaS services have been doing for quite some time now. So you can create and manage private endpoints for the gateway of your API Management instance. Now, there are some limitations with it right now, at least in preview. Some of them may be addressed when it eventually goes GA, but it only supports inbound traffic coming to the gateway. It only works on instances using the STV2 compute platform, and it doesn't work on the consumption tier. Also doesn't work, you can't combine it with virtual network injection. So here's an example of how it might work. So in this case, you have contoso.azure-api.net gateway, which has a private IP of 10.0.0.6, which is only going to be available to resources within the Contoso APIM East US VNet. So this allows resources in this virtual network to securely communicate with the APIM. And other resources may be restricted to resources only within that virtual network. Now, at the moment, these three options are mutually exclusive. So you can't choose virtual network integration option, external or internal, in combination with private endpoint connections. Also notice that only our managed gateways will support the private endpoint connections. So the self-hosted gateway does not support private endpoints in Azure. Going into what's now generally available, so there are new members in the EV5 Azure VM family. So these sets of VMs are usually used to deploy large database workloads, such as online transaction processing systems and analytical applications. They're extremely memory intensive, so they're memory optimized. But what we found is that often a lot of these applications require really fast disk performance as well. Sorry, somebody needs to go on mute. Let me just fix that. You participant. There we go. Okay. Yeah, with Ray. All right. Okay. So these new members that have joined this group provide like really super fast performance in terms of disk, in terms of IOPS, which is input output operations per second. And let me get back to that. So this table shows you some pretty impressive numbers here if you're really interested in reading IOPS figures. Also, GA is service tag support for user-defined routing. So user-defined routings, of course, obviously is how you control your network flows. And what you can do is that you can now attach service tags to it. And if I understand this correctly, and hopefully somebody will tell me if I'm talking through my hat, the service tags will now update automatically to include any changes that those services make to their list of published IPs and endpoints, so that you don't have to quite do that manually, where you'd have to upload a JSON file to do that. The other thing is Azure Databricks Delta Live Tables is now generally available. So this is apparently a framework for building reliable, maintainable, and testable data processing pipelines. So they've updated the pricing model of Delta Live Tables based on the feature enhancements and feedback that they have. It'll be charged based on the DLT service tier, which is Core, Pro, or Advanced, chosen at the pipeline creation time. There is no price increase as a result of these changes. Yeah, if you want to learn a little bit more about that, you can go to that link at the bottom of the slide, which I've put on all of these slides, by the way. And I will share this deck so that you can go and investigate this stuff a little bit more in detail if you wish. And the last update I have is what's gone GA is glossary terms in Azure Purview Data Catalog search. So obviously these glossary terms are things you can provide definitions, synonyms, and acronyms and stuff, and they can be tagged to assets to basically help self-document the solution. Now, apparently they're available in the search results as well. Oh, some of the resources we have available to our group. We have a Slack community, so please feel free to join this if you haven't already. People get on there and they post questions, and the community is quite large. It's quite a lot of really smart people on there, not like me, and who are really good at answering questions. So definitely join that Slack team. We do have a YouTube channel, and we push the recordings up to that channel. So tonight, obviously being recorded, as in so many of our other meetings, and just give us maybe a few days, like maybe beyond the weekend, and you'll see tonight's recording up there. But definitely join and subscribe to the channel. As far as training that's available in Azure, we've got a few different things there. So 30 days to learn it. So Microsoft offers a lot of free training. If you want to go for more paid training, there's always, of course, Pluralsight and Obscurity. And these blogs are an excellent source of information. In fact, they're the source of some of the things that I presented to you tonight. So always good to check out the two Scots and also the IT Ops Talk blog and the Azure blog. So without further ado, I'll introduce tonight's speakers to you from Codify. Actually, is it Codify or Codify? How do you pronounce that?
Codify is the Australian.
Codify is the way. Okay, so David and Dan are going to give us a great presentation on app modernization. And without further ado, we'll jump into them. So let me stop sharing my screen. And take it away, guys.
No worries at all. Thanks very much, Dan. Hello, everyone. I'll just get my screens organized. Hang on for a sec. Thanks for coming along. So the agenda of what we want to go through tonight, we've got a fair bit to cover. So the first few slides I'm going to tear through at a great rate of knots. But essentially what we're going to talk about is just, I guess, the journey that we take customers on when we look at taking an existing on-prem application and moving it to the cloud. So we'll talk about what is PaaS. I know it's probably a little bit basic for the audience, but what the goals are for app modernization. We're going to drill into a case study on an application that we helped a customer get to the cloud, which was being developed by a vendor that wasn't us, who was very anti-cloud, and what we did to sort of get that over the line. Talk a little bit more about, I guess, our approach to security and cloud security and how that relates to app mod as well. And then we're going to drill through the anatomy of what we consider a modern app to be. So it's basically a series of things that one would do on-prem or traditionally would do on-prem with applications and what their cloud equivalent would be. And then we'll close it out with a bit of a sort of a few home truths that we sort of come across along the way about how you sort of save money when you're re-architecting for going to the cloud. Now, if anyone's got any questions along the way, type them into chat, and then Dan will interrupt and we'll just address them as we go, so we don't have to circle back at the end. So just a little bit on us. So my name's David Connors, obviously. I'm the Managing Director of Codify. I look after our managed services side of the business. And Dan, if you want to say a few words.
Yeah, so my name's Dan Van Eyck. I'm a software engineer with Codify. Sort of started 18 years ago with .NET 1, or before that Delphi, and lived all the way through to what we have today in cloud. So
yeah,
to you, David.
And then yeah, no worries. And then, so what we do as a business is essentially we talk about our three pillars, which are plan, migrate, and run. So plan is our sort of methodology / system that we have for mounting an evidence-based business case to get people to the cloud. Migrate is the area of our business where we move people to the cloud, obviously, and then run is our managed services business where we help people continually optimize and be the best they can be in Azure. So probably the best place to start is really a definition of what app modernization means. And when we go through and grade applications to do as part of a cloud lift assessment, we sort of look at it through the prism of these sideways traffic lights, if you like. When we think about what app mod means, really the goal is all about lowering TCO as much as we can. So the best thing that you can probably achieve, obviously, when you move something to the cloud is to delete it and not take it to the cloud at all. That obviously yields you the biggest saving, and you'd be surprised to find how much money we save customers when we move to Azure by just turning things off. But then, if that's not the case, then obviously moving to just a subscription-based software as a service model is the next best thing, and so on. When we look at architectural patterns that you follow, really, if you're going to be modern, everything's got to be web-based. from a front end, and so there's no app deployment issues to deal with. Mobiles being a bit of a special case, and then you want to take a lightweight approach to integration, which in this day and age is really REST and JSON as a preference over any of the WS Star SOAP type technologies, as a preference over really old school COM+ and EJB type stuff, which we see floating around a lot. And then I guess the last part to that is taking a modern approach to authentication. So people logging onto Windows applications or authenticating against SQL inbuilt principles is not really the best thing to do in this day and age. So we sort of look at this through these three pillars, or these three traffic lights, if you like, as being worst to best. Obviously, if you've got a desktop application that someone's written in VB or C++, and the one that we actually find most often, especially for small departmental applications, is heaps of MS Access kicking around. You don't really have much of an opportunity to modernize the app. You just got to torch it and start again, or move it to something like Azure Virtual Desktop is really your only option in that case. The second bucket is where you can have legacy apps, which they might look modern. They could have a web front end on it and be quite good to use, but behind the scenes you're going to find binary libraries that possibly can't be run in a PaaS environment. People adhering to the old N-tier architecture, your ActiveX and those sorts of things. And so in those cases, you're probably looking at a partial rewrite to get it into something like App Service, and then that's sort of probably anything from sort of 2012 before. But then obviously the gold standard is when you find people who've written modern applications, and they can be, we're not precious about things having to be written in .NET. They could be written in PHP or Ruby or anything really, but generally those sorts of apps require minor tweaks to get to the cloud, and do it in a very cost-effective way. So probably everyone here has seen this diagram, so I won't dwell on it too much, but that's just that classic view of where the value is in each of those stacks. And we're very clear with our customers when we do an assessment to get them to cloud. We want to get them to SaaS, as far as we humanly can, even if it means there's no Azure revenue for us or no project revenue for us. It puts them in the best case. There's always still in the enterprise, there's always plenty of IaaS kicking around, and that's going to be the case for a long period of time to come. So we'll talk a little bit through a case study with a customer of ours. They've had another agency developing a genomics application that was doing DNA sequencing and the associated lab work, supporting a couple of hundred scientists who are breeding better things in their field. And it was being built by an external developer who was extraordinarily hostile to cloud technologies. They openly said that it's never going to run in Azure, which we sort of quizzically looked at them and said, I'm sure it can if you did your job properly. So we'll talk about how we went through what we did in terms of the things that we found in the application and how they were remediated. Basically, our approach was to go and do a source code level review of the app, identify those anti-patterns, and just create a resolution plan for each of those, and then implement them through to production. One of the things that we'll share as well that was I guess it's a thing that we've ripped off out of one of our statements of work that we use for when we pitch to a customer to modernize an application. We've got a series of grading criteria. Dan, if you just want to grab that link and just drop it in the chat for everyone so they can download a copy. But basically, we have a series of talking points that we go through in workshop with customers that sort of grade the application based on some of the criteria that we're talking about in this presentation, and talks in terms of what the undesirable artifact would be on-prem and what the desirable outcome would be. And so I've taken that out of our template and just turned it into a standalone PDF. So you're more than welcome just to grab a copy of that if you like. And if you've got your own app mod things that you're trying to do at work, it'll be pretty helpful for you to just to have a place to start, and the right questions to ask developers in order to move the conversation forward. So going back to our case study application, so the app was pretty bad in terms of how it handled auth. It was all forms based, back ending onto a Windows domain, which is okay, it would work, except for the fact that they have a couple of hundred scientists that work. They're an industry body, so they obviously had to do a heap of work with people outside their organisation. So it was not feasible. I mean, I guess it could, create CorpNet accounts for all those people, but not very recommended and not a good security practice. So So we just suggested that we just delete all the authentication code and replace it with EasyAuth, which is a feature of App Service, which just gives you a simple turnkey solution to do claims-based auth in Azure AD, and that just knocked that one on the head. So in the case of fixing that cloud anti pattern, the corrective action was deleting a whole bunch of authentication code that they'd written and replacing it with just a simple check for some of those easy auth claims that are passed into the application once the user successfully authenticated against Azure AD. And then that obviously opened up the door to them being able to do Azure AD B2B invites in their tenancy to get these external parties in and being able to manage them in a way that didn't require that they got into the business of issuing credentials for them. They're just using their own company credentials and so on. So that was a good outcome. Dan, you want to talk to these points a bit?
Yes, thank you. So the next part of the app we looked at was the storage concern. So most enterprise app will have some sort of SQL backend, and so in this case, they were using some features in SQL that aren't supported in Azure, namely file stream. So if you're familiar with file stream in SQL Server, it basically lets you interact with SQL and give it files to store, and it's just transparently stored as a file stream behind the scenes. You can then retrieve it back from SQL, and if you do backups and that kind of and restores, sort of those concerns have to live with SQL. That isn't available in the cloud. So what we did in this case is rework the logic slightly to store those documents in Azure Storage as blob files. And so the first part of operation would store the file in Azure Blob Storage, and then once that's stored, store a pointer to that document in SQL. That would mean you couldn't have a SQL record that's orphaned from the actual file. You could end up with files in storage that don't have a SQL record, but you deal with that at an app concern. More worrying would be if you think a file exists that doesn't. And by doing that, we then decouple the SQL database from storage, and they can scale independently. And you can also utilize all of the benefits you get with Azure Storage. For example, file history, file audit changes, lifecycle management, all that kind of thing. And also the SQL database can be backed up and restored without bringing all those files across to, say, a development environment. The next bit we looked at was also logging. So most apps will have logging of some sort. Usually they'll be writing to, using something like Log4net, writing to the disk, and you have to deal with all the concerns like what happens with the file gets too large, do we roll it over to the next day, or do we truncate it, as well as the operational concerns, which is usually not thought about ahead of time. So how does somebody actually get to the logs? Do they have to log into that server, which means they've got to have high trust to get to those logs in the first place? And so the solution there is Azure App Insights. We replaced the logging with, they were actually using, I think, Serilog in this case. So we added a shim or a sync to write those Serilog logs to App Insights. And that immediately takes care of most of those file storage and retention concerns, or log storage and retention concerns. You get a good dashboarding out of the box. A lot of sort of AI capabilities in terms of new or unusual error activity that might be happening, slowdown of the web app, all features that you wouldn't traditionally have with a regular logging framework. Next we moved on to the label printing. David, do you want to say a few words about that one?
Yeah, sure. So the label printing was, you wouldn't think printing's an interesting topic. In this case, it kind of was. So when they're working in the lab and they've done some DNA thing and they've got a little vial, they have all these barcode printers scattered throughout their laboratories across the state. And so they needed a way for this app service to be able to do a directly addressable TCP socket to the printer to send it the instructions to print the label. At the time that we did this, VNet integration had just come out, so we were able to use traditional Azure App Services for the deployment of the app rather than having to use an ASE, which is obviously a massive cost difference for the customer. Just by enabling VNet integration, very straightforward. It's become the norm, I think, now for most customers we see doing these sorts of integration scenarios. So, and it's, I think, stood the test of time and proven to be pretty reliable. So that was how we sorted that issue out. Dan, about DevOps?
Yeah, so next bit of the solution we looked at was the actual dev tooling that sits around the application. So in terms of DevOps, they were using various open source tools, Catalan for driving tests, on-prem servers hosting, I think it was TFS installed. You used Jenkins for builds, all sorts of various different disparate tooling that had to be maintained by the team. And another drawback of that was that the client themselves didn't have any visibility over what work was being done, what deployment is in which environment. Essentially didn't have any control of their own destiny in terms of promoting releases to a test environment so the testers can start testing. There was also concerns with the IP not actually living in their own tenancy either. So for that, we moved them over to Azure DevOps. And if you're familiar with that, it's got all of the pieces of the software development lifecycle tied into it. So immediately they had visibility over what was getting checked in, had control over the source code or the IP that's being developed. And because everything was being deployed out of DevOps into Azure itself, the testers could see what version is deployed and then promote a new release whenever they wanted to start testing and get that full traceability throughout the stack. Dave, do you want to go on to the security?
Yeah, sure. So, yeah, I guess this is going back a little bit on what we were talking about before with VNet integration. We'll touch a bit on Xero Trust as well. If you looked at Azure 18 months ago, which was probably about the time frame, 18 months, 2 years ago, when sort of VNet integration was starting to be a thing and private link was starting to be a thing in terms of being GA and broadly adopted. Prior to that, all the public cloud services, funnily enough, were public by default. And you'd often get a lot of friction from customers when you talk to them about adopting things. They say, oh my God, is this Key Vault going to be on the internet? Oh my God, is this app service going to be on the internet? But now that you've got VNet integration and private link, I think that's sort of changed the game in terms of security posture for people as well, that it gives you a lot of flexibility around choosing what you need to have face the inside network versus what faces outside, and the level of coverage that you've got across services now is there's dozens and dozens supported. So it's definitely something that I would say everyone should be adopting. And I think it's become the norm now, certainly for enterprise customers. If you're building a website, sure, you'll just chuck an app service and face the internet, but for anyone else, I think we're seeing just really heavy use of private link as a standard thing moving forward. The other thing that I guess is an interesting point of conflict that we have when we talk about app modernization as well is the concept of Zero Trust. We certainly find the enterprise in general, enterprises are quite they're quite behind the times in terms of things like network perimeterization, and you've still got quite a few network security people who are definite holdouts for wanting to perimeterize everything within an inch of its depth. And my standard argument to that, which normally wins, is, well, when you pay your suppliers their invoices, you do that banking over the internet, and when your CEO's phone syncs his email, it's over the internet. So why are you so worried about a particular web application? You should just be satisfied with securing it by identity, and of course taking all the appropriate controls and MFA and so forth. But it's I think there's still a way to go to get people on board with that way of thinking across the board. And in a way, private link and so forth is going to, I guess, force people to go backwards a little bit, I guess, in terms of using technologies like that to build out heavily demilitarized networks, which ends up driving the cost of the application up by the time you start dropping WAFs in front of simple web applications and so on, and then you end up with an initial cloud adoption barrier, because if somebody wants to have service plus preventative measure A, B, C, D, and E, but they're only deploying one application, then suddenly the cost benefit for the deployment of that one application doesn't stack up very well. So next thing we want to dig into is this sort of mirrors that handout which I provided the link to earlier. We're just going to talk through each of the things that we see people doing on-prem in general and what the equivalent cloud version of the technology is. So some of these might be a little bit overlappy from what we did before. Oh, actually, that was one point that I wanted to talk about on that that application that was written, that genomics thing, I can't remember. I think the customer paid the other agency something like it was $1.5 or $2 million to build this application that they were absolutely certain could never go to the cloud. And our remedial work, if I recall, was something like about 70 grand. So when you think in the context of an application of that size, it was a big piece of work. The remedial work we had to do was almost nothing, and just a rounding error in the overall project budget. So it just goes to show, I think, when people start throwing up sort of blockers and reasons why things can't happen, if you can just take that pragmatic approach, get that guide that we put there before and just go through the issues one at a time and just knock them over. Provided they're in that yellow to green section on the traffic lights I presented earlier, it's a finite amount of work that you can just push through. Anyway, Dan, you want to have a bit of a chat about just this particular?
Yep, yeah, for sure. Just to add to that, the remedial work we did for 70K, probably if you didn't do that and you actually had to, that money that they spent was just for development. But if you had to get operations ready for somebody to support it without going to the cloud, you're probably going to spend more than that anyway, in terms of just making logs visible and getting people to understand how to deploy it and various bits of tooling. So there's a lot of efficiency savings to be had by making an app like this cloud ready. Speaking of which, the first thing you'd look at is the SDL software development lifecycle before you even start, if you had your choice. So nowadays, what we do is recommend starting with DevOps, or Microsoft's also moving a lot towards GitHub, which was acquired by them. So either one of those two, just because and ideally don't install any self-managed servers or on-prem servers, so you don't have that kind of maintenance overhead. But both those systems would then easily dovetail into Azure for deployment. And then in terms of the feature set, it covers everything from being able to host the source code, which can be both TFVC or Git if you're looking at Azure DevOps. Highly recommend don't use TFVC, just stick to Git, because you don't want to have file locking and all the legacy sort of concerns that would get introduced with TFVC, and Git just a lot better in terms of branch management, merging, a lot of productivity gains to be had there. Boards to do work item management, backlog management, sprint management, also providing traceability for those work items to the source code level and then being deployed by the Azure pipelines. Were built by the Azure pipelines, ready for deployment into Azure via Service Principal that is just hooked in. There's also testing functionality or test plans, but we don't really see too much use of test plans. That's sort of moving away from that to load testing, Azure load testing, and that kind of thing, or Selenium if you were to do automated UI testing. So once you've got the software development lifecycle tooling set up, the next bit typically we move on is the SQL side of things. Dave, do you want to have a chat about that?
Yeah, for sure. Just one last point on the whole DevOps thing as well. Obviously, one of the things customers ask us a lot about is the GitHub acquisition. GitHub doesn't have, in practical enterprise development, it doesn't have the features that you need in terms of doing workflow management. It's still so far behind Azure DevOps. So we generally, we use Azure DevOps exclusively, and we recommend our customers do in a corporate setting. If you're doing some sort of open source project and you've got broad-based collaboration where you're not trying to do tightly defined budgeted work, GitHub's probably fine. But I don't know. It would be interesting, maybe in a future user group, if there was someone who could really talk to what the roadmap is, because I'd certainly like to know. Obviously, Microsoft's, the rumors we hear, they've taken all the staff out of Azure DevOps and put them into GitHub, but there hasn't been very much evidence yet of getting the features that I think enterprise devs really need over the line yet. So we'll see what happens with that one. So next thing is really what are you doing with your data tier in the cloud. So obviously on-prem, it's Windows and SQL Server is where it's at probably for anyone on this at this user group. Look, I mean, the reality is that the performance of, if you have a modern server and you've got NVMe storage attached to it, SQL Server performs very well on a dollar for IOPS basis, but the hidden costs that people never look at when they do those initial calculations is what do you really need in terms of human resource power or from an MSP or whatever to support HA. And having that run properly and having that tested regularly and managed is always where the cost is hidden, because SQL Server does a very good job of limping along and being poorly configured for a long time until you need it. And when you need it, you'll find out, the implications of that poor configuration, right? And so a number of times you see people where they've lost logs because of poorly configured storage subsystems and so forth that stuffs them for backup and DR. Obviously Azure SQL Database, it's the PaaS edition of SQL Server. The fidelity, for all practical purposes, I mean, it's not 100%, but it's pretty much 100%. There's a lot of things that you can't do in it, but I would argue the patterns that aren't supported in Azure SQL Database are generally poor patterns. I mean, if you're writing .NET code inside a stored procedure, that's not a great way to write applications or a great place to put .NET code. So the fact that that's not supported, that sort of don't really shed a tear for that. You've got the ability to jump between price points pretty easily, but the main thing from my point of view is the key driver for why you would ditch running SQL on-prem or SQL on IaaS as well is the fact that scaling backup and DR is taken off the table, because that is the one thing we see all the time when people do it themselves. It's always done poorly. So I think that's the major value prop there, from my perspective. Dan?
Next, we'll look at the web server technology, or IaaS, on Windows. So traditionally, what would happen is the ops department would set up a IaaS website that would be set up with certain bindings and certain features enabled, potentially machine configs with overrides, all manner of configuration would be done. And the problem with this is it's of course pretty error prone, and not necessarily repeatable. Consistency was an issue. So if something goes wrong and the server was reprovisioned, nobody knows why the app doesn't run, because all those steps could have been done manually, and you've got the large surface area of Windows Server to consider. Publishing those to the internet involved a lot of firewalls and proxies and various network configuration steps. So in Azure, we've got App Services, which is a very mature offering from Microsoft to host web apps. You can build them on many different languages, pretty much any modern language. The whole concern of configuration and updating and publishing to the web is all handled as a PaaS service by Microsoft. So that if you've got a web app running and you had to redeploy it, there would be minimal. The surface area would be minimal for configuration that could go wrong, and typically you would automate that in DevOps anyway, so that it's just a case of making a new app service, point DevOps at it, and redeploy, and all those settings, because it's such an opinionated way of hosting a web app, would all take effect on that new app service. It also allows you to be up and running within minutes with a highly available, possibly geographically distributed web application with as much processing power as you want to pay for, which would always have been a very big deal if you wanted to accomplish that same thing on-prem. Months of acquisition time to get server set up and networking done, all that kind of thing. So great step forward there. David, you want to talk about the Active Directory?
Yep. So, and this is obviously a very fundamental topic to talk about to everyone at this user group. But obviously, AD is what everyone's used for 2 decades now, more 2.5 decades, versus Azure AD being the cloud-based alternative. But what it really means in terms of app modernization, if we think about identity as the perimeter and network security, if you were to build an application hosted in IaaS using Windows Auth and expose that to the internet, which is perfectly acceptable practice 5 or 10 years ago, you're leaving yourself pretty exposed. We didn't have the cyber posture issues 5 or 10 years ago that we do today, especially with global instability and a lot of state-based actors getting up to no good and people crypto lockering networks and all that sort of stuff. If you want to secure it, do some basic security on your application by just saying, look, anyone who's outside the Australian geography has no business accessing this particular application if I'm a Australian government department, and just knocking all of that traffic on the head at the authentication layer. You can do that, but you obviously can't do that on-prem. So yeah, we'd always recommend using Azure AD for authentication, and even if you're trying to do modern-based authentication using SAML, the other technology, it's still kicking around from Microsoft, which is a good old ADFS, still supported for some scenarios, or recommended, unfortunately, for some scenarios. Again, it all comes down to cost of ownership. Keeping ADFS fed and watered is a pretty arduous job. And if anybody here has ADFS and can tell me hand on heart they've never had an ADFS certificate expiry issue causing problems with their application authentication, I'll buy a beer. But everyone who owns it does, and for most people who don't have someone looking after it as a principal part of their role, it's probably every 12 months. So always recommend Azure AD, but mainly I think the value prop, in this day and age is really what it brings to the table in terms of threat protection, and also in the context of that application remediation exercise that we went through before. B2B and being able to do B2B trivially is a huge benefit for people as well. So next part really I think is key to talk about is what we're doing with storage in the cloud as it relates to AppMod. So Dan, do you want to have a bit of a yak?
Yeah, so most web applications would at some point probably try and write some files to disk or read files and move files around. And so what you would always find is that there's a file share set up for the organization, and you would need access to that file share and just use file IO APIs to write to them. This introduced a lot of operational demands on the team, because you'd have to make sure that enough storage is always available as the app grows. You'd have to anticipate what sort of size might be needed in the future. So capacity planning, storage backups would be responsibility of the organization, and whether those backups are reliable and whether you can restore them is another question as well. And any advanced features that you might need, such as file soft deletes or file versioning, you'd have to build into the application logic itself, or at some level. In the cloud, this is or in the Azure, this is replaced by Azure Storage, which has blob storage available for writing files, file shares, and simple queuing as well. So if we look at blob storage, there's a REST API to interact with it, and various SDKs, and covering most modern languages. And it's simple to see if you just look at the basic features that you get unlocked by Azure Storage, like versioning, point-in-time restores, immutability of the data or legal hold, change tracking, soft deletes, all those features just being available out of the box. It makes it clear to see sort of the value you get out of that product offering. It also dovetails nicely into other Azure services, such as Synapse or Functions or Logic apps, because of it being a first-class citizen in Azure, and all the other services understanding it. It's very easy to consume any data written into that storage account across the Azure landscape. Next, we look at reporting. David, do you want to have a talk about that?
Yeah, sure. Just on that point though, out of all those benefits you talked about, the red hot one out of that, and when I put my cyber hat on today, right, is storage immutability, which is a huge issue. When you see the financial damage that happens to organizations when they get cryptoed, and we've seen one organization get cryptoed and their backups get cryptoed, which they obviously wasn't a great time for them. Just having out of the box storage immutability that you can trust is a huge benefit. So hopefully Mr. Toomey's not wincing too much at this slide. So I saw the preview come up. I thought he might not think that Power BI is a good substitute for SSRS, but SSRS, I mean, it's the de facto standard that turns up for time and time again for all sorts of departmental reporting requirements. It really is abandonware, in terms of you try and go and get it running on a modern Windows OS, good luck. But the cloud alternative is obviously Power BI. Now, I'm not going to lie, Power BI is not the world's best tabular reporting solution. So the sorts of workloads, Power BI is a superpower, is cranking out fantastic dashboards, and you can do tables of data in it. But if you've got a requirement that has that needs a lot of tabular reporting, Power BI is heading that way, and it's got the Power BI report writer now, which looks suspiciously like the SSRS report writer, but it's still, if you've tried to use it in anger, it's still a bit rough around the edges. But regardless, that's where you've got to really head, I think. We've had pretty good success using AG Grid, like third-party grid controls in the context of Angular applications for those sorts of tabular type reporting solutions. And you can build it into a nice Angular UI and give people good performance. But yeah, so Power BI is really the place to go in that case. The other thing that is very thirsty to run in the cloud is anything to do with SSAS. The old school way of doing any sort of analytical services in the cloud needs about infinity bajillion gigs of RAM. And if there's one thing that drives the cost of infrastructure as a service up, it's RAM more than anything else. And so, what's your solution for a modern posture in the cloud? Well, it's Synapse. And what's the migration path between the two? Not great. It sort of is heading down a bit of a rewrite path. But I think you have to embrace, if you're doing any sort of BI data warehousing thing, you have to embrace this modern sort of compute on demand worldview, because when we do cloud lift assessments for people, if they've got a BI department, the figure comes up time and time again. It's 50% of the cost of their IT is taken up by BI, and 50% is taken up by the rest of the company existing. We see that many times, and that's just because of the sheer heft of the hardware that you've got to throw at those solutions. Certainly when you get any of the SAP products in the landscape, it gets a bit out of control. But if you can reposition your application as you're taking to the cloud into using a lot of things like SQL on demand, and just back-ending as much of your storage into boring old Gen 2 storage accounts, they're incredibly cost effective. As Dan mentioned before, they really work well for dovetailing into Azure Storage. Like Synapse and Storage are like two sides of the same coin, essentially, for data access. Dan, have a chat about logging.
Yeah, so usually the traditional apps would be logging to either local log text files, which might roll one every day, or you would be finding the logs in the Windows event log. And the problem with that was a couple of problems. Firstly, a high trust requirement. So any engineer that needs to go and look at the logs, say it's the Windows event log, would have to remote into that VM. So you'd immediately need that kind of permission. Then you'd have to troll the logs throughout the Windows event log or that log file, and what you have is still just a line of logging, which is whatever you've written, and no way to really aggregate that or make any sort of analytical decisions about that. Data would keep growing over time, so you'd also have to look at monitoring that growth and trimming those logs as time goes on. So with App Insights in Azure, this allows us to get those logs to exit wherever the workload's running and bubble it up to Azure Monitor. And from there, we can do various things with the logs, from looking at the actual logs without having to have trust in the app itself or wherever the app's running. We could look at performance metrics, aggregate those over time. So see, for example, if you've got an API, which API endpoint's running the slowest. Look at performance characteristics over time. So is it slowing down after a certain release from DevOps? As well as looking at a correlated sort of a log where I might have an error that happened, but I actually can see that it did a SQL call and the store procedure failed, and how long was spent in each part of the app versus from the API down to the store procedure level. So a lot more making sense of what actually happened than just a line of text that was logged by the application. You can also look at setting up alerts, which again would have been a problem if you just had those Windows event logs. Need a solution for that, but with App Insights, we can just create a custom query, which is a SQL-like language, to query those logs and then hook that straight into the Azure notification framework or alerting framework to alert ourselves that something is wrong and needs attention on a regular basis. Next, we have sort of background processing that would happen. Most apps have some form of batch process or background process that takes place. Usually that would be written as a Windows service or a task scheduler task. And these would have to be deployed to a VM running somewhere, and would typically just continuously poll something for data to be done or fire up on a certain interval and do some work. Again, this introduced the problem of how this is operationally handled. So how do we administer this task? Somebody might have to remote into the server and restart it or start it up, see what's going wrong. Permissions, it would typically require some relatively high permissions to run. And you'd have a service account that would set up to run under, and inevitably that password would be either widely known because team members would have to set it up and supply it to these installations, or it would be written down by developers. The password had expired potentially, and the service stops running. So again, a operational issue introduced by that framework. No centralized ops or reporting. So across the organization, what Windows services would be running, is anybody's guess, and what state they're in. So in Azure, we can replace this with Azure Functions. So that's a framework where we can write a functional code in various languages that respond to a certain type of event. So it might be a continuously running task that polls, or it could be a timer, a cron schedule might respond to a new blob being written in storage. All manner of triggers that could trigger the piece of logic. But this can run out of band from your web application, thereby not affecting the processing power that might be dedicated to that web application. And the development experience is a lot easier as well than a Windows service traditionally would have been. Of course, the operational concerns of function or logic apps, for that matter, is a lot better because it dovetails straight into App Insights. We can see what's run across the organization, monitor functions for being failing or whatever state it's in. And the identity story is a lot better as well because it supports managed identities. Essentially, it can have its own Azure AD backed service principal created. Nobody needs to know the password, but we can still provide it access at a blob storage account level or a key vault level to access those Azure resources, but no password expiring. Nobody needs to know that password, write it down or set it up. Scalability also a lot easier because it can run in the cloud, and we don't need to fire up a new VM every time for another Windows service. So a lot better in terms of that dynamic scaling. Next, we would, if we look at scaling out a system, traditionally we'd use something like MSMQ or RabbitMQ. For David, if you just want to go to the next slide over there, sorry. We'd use a message queuing system to scale out the system, that's the first reason we do it. But the other reason would be if you want to set and forget work to be done in the background, you might use a message queuing technology like Microsoft Message Queue or RabbitMQ. These again would have to be installed on a dedicated server, and you have the operational overhead of maintaining those, making sure they can scale out appropriately, storage is in check. In Azure, we can replace this with Azure Service Bus for messaging and queuing. It supports both standard first in, first out queues or more advanced topic and subscription models. But because this is a full-fledged PaaS service, we can scale up and down on demand. Cost of entry is very low. Programming models very simple. Also supporting the protocols that you would have used with something like RabbitMQ or MSMQ. So not a lot of work to do to transition if you want to keep those protocols the same. But this allows you in Azure to scale out those concerns by putting a message on the queue and then say hooking up a function, Azure function, to that queue to respond to whatever the request was.
Hey, Dan, just on that previous slide, do you want to talk a little bit just about the interplay between Azure Automation and Azure Functions? Because I think there's an important point to make there.
Yeah, sure. Yeah, so Azure Automation is a pretty good system to be for sort of operational concerns. If you might have a PowerShell script that you want to have run on a regular basis. So you can just write that script on your dev workstation, and when you're ready to actually get that to run on a regular basis, upload that straight to the cloud, and they would execute that on. You can either have a webhook that you can call or a schedule that you can set up to run that. There are some limitations to that because I think you can't run it more than every 5 minutes or 15 minutes it was. So in terms of a schedule, there's some limitations. And it also can run into some issues when you have, let's say, you have a PowerShell script. If there's actual errors that occur, you won't necessarily have those bubble up as a failure in the automation runbook. So we've seen that come across that a few times, versus a function. Much better scalability, designed more for sort of C# code or succinct code that's supposed to actually execute and complete in a reasonably quick time frame. And the experience in terms of has a function failed or succeeded is a lot more, I guess, reliable than that. Both those can reach into your network, but if you use Azure Automation, you can deploy a hybrid worker and actually get that PowerShell script to run inside your network, more sort of in line with what you would have usually done with a scheduled task in Windows.
Yeah, and I think disappointingly, again, in 2022, we see time and time again when we assess customers' infrastructure that enterprises very much run on Windows Task Scheduler. There's always a server that's got a bajillion tasks on it doing different things, and there's no centralized pane of sort of reporting for when those things go wrong. Generally speaking, it's quite often you'll log on and you'll say, oh, there's 25 scheduled tasks on this machine, and 0x some error and 0x some other error on half of them. What we're able to do for our managed services customers is because automation gives you a single surface area for all automation jobs across the entire customer. It makes monitoring really simple. No matter what you're doing, all different, like replicating AD records into some HRIS system or whatever it is. At least when that fails, you've only got one place to go and look for every sort of I guess nuts and bolts PowerShell type orchestration thing that you might hook up as a day-to-day sysadmin. So secret management, Dan. Oh no, me. That's my name against it. So yeah, all right. Secret management. No one does it right. Again, when we troll through our servers, customer servers for assessments as well, you'll always find PFXs lying around. Find a web application. It's nearly a dead cert that there'll be unencrypted credentials in the web config. And certainly if you're talking about anything from the free and open source community, WordPress and those sorts of applications, that's the norm and still the norm. They don't even sort of appear to be making any effort to try and go down a better path of development. When you migrate to the cloud and when you modernize an application into the cloud, it's a really good opportunity for you to break with those bad habits of the past. And so the key tool for doing that is Azure Key Vault. It gives you a way of storing arbitrary secrets or username credentials or certificates in an abstracted security store that has not just the Azure RBAC security controls over it, but additional firewall controls that you can use to really lock it down. And the idea there is that you'd have a production one of those running, and you'd have production credentials in it that are managed by a trusted security operations type person, and the developers would never even be able to get those credentials. Only the application code running in the production environment at runtime can, via various locking it down with credentials and service principals, security, and so forth. So it's something that you really, really want to look at embracing. It can be a fair amount of work to do a good implementation, depending on how much access you've got to the application that you're modernizing, but definitely something that's well worth doing. The other thing that you can do in it now as well with Key Vault, which is quite cool, is a lot of services like App Service, Front Door will support binding to a Key Vault for certificates. And for a given certificate in there, it will always automatically look for the most recent version of that certificate to be published. So if you follow that across the board for all your SSL certificates for your applications or Front Door and so forth, come certificate renewal time once a year, you just need to grab that new certificate and drop it into the Key Vault as a new version of the existing secret, and then that'll roll out to all of those services with Zero Touch, which is a really great feature. Funnily enough, I did engage with the support guys at Microsoft. When you buy a certificate through Azure using the managed app service certificate and bind it to a Key Vault, it actually puts it into the Key Vault as a secret, not as a certificate. So that makes that feature I just described not work when you buy certificates through Azure itself, and they confirm that is the way the product's supposed to work, which completely baffles me. But certainly that notwithstanding, if you do have, even if you're using that certificate issuance service within Azure or an external one, even if you're using one in Azure, it still makes sense to go down the path I just described, because it means you don't have to touch the application services when it comes time to do an upgrade. So the final section we want to talk about was really just a couple of, it's a bit ranty really. I don't know where it fits into the rest of this presentation, but just a few things that we see during app modernisation that we thought we'd have a bit of a chat about, that are, I think, accepted processes perhaps that people talk about that we disagree with. First of those is app service environments and the reason why they exist. If you read the docker on it, it's billed as being a highly scalable service, and it's just not. It takes 4 hours to scale. We've had situations where we've deployed an app service and it encountered an error during deployment, which wasn't noticed by the people doing the deployment, and proceeded to deploy an application to it. So it was running fine, and it just got deleted the next day. And you talk to the guys at Microsoft and say, well, why did this service suddenly get deleted? The site had a deployment error, so in the next 12 to 24 hours we delete the service. It's like, okay, that's probably not a feature I would have implemented, but anyway, stamp fees are obviously excessive. They're no longer the case with the new version. I think it's ASC v3 they've done now. You don't necessarily have to pay the stamp fee, but they do charge you for a minimum number of isolation workers, and the isolation workers are priced prohibitively, like relative to just normal boring old app service. And the other thing is there's no migration path from ASC v1 or v2. So if you've been a good little egg and early adopted this, to get away from that $2,500 a month stamp fee for essentially no business value, you have a migration path which is a complete rebuild. Slow to scale, as I mentioned before. Scale operations can take quite a while. There's a lot of stuff in ASC that just doesn't work as well. The ability to do integration with Azure DevOps, for example, all those UI, it exists in the UI, and you just click on these things, you get various areas out of the portal because it's this sort of unloved child service. And I think also, private link obviously and VNet integration has completely shot the business case for app service environment in the foot. So we've done several projects for customers migrating their apps off app service environment onto app service using VNet integration and private link. One of the guys that we did some work for had 60 or 70 various web servers. They're highly advanced business, a very mature DevOps, lots of integration between CRM and finance and all this sort of stuff they've written. It's really, really well put together, but and that's heavily used with a big e-commerce footprint. Been no problem at all in using private link and VNet integration in that context at all. I don't know whether you want to talk a little bit more about that point, Dan, or
yeah. So yeah, that's right. So part of the issue with ASC is because it relies so heavily on not being visible outside your network. Most of the tooling in the portal doesn't really work well anymore, because as soon as you click on it, it's the traffic is not necessarily from in the network. So you end up with all these workarounds in order to get to the Kudu endpoint or the SM endpoint. DevOps has to have a custom agent inside the network in order to deploy, so that cost of ownership goes up. And it's just generally the features. For example, there's a diagnostic and troubleshooting blade on the web apps on app services. Very useful, and it gives some very good information about what's wrong with your app, why it's down, and so forth. That lags behind again on the ASEs, because whatever logic the team of Microsoft writes for an app service can't readily be applied to an app service environment. So you generally just feel like you're getting a bit of a second-hand experience running on an ASE. Go on to SQL.
Yeah, so next thing is just really about how you use SQL, and I think there's a lot of missing logic in how it performs. I mean, you can buy SQL Server based on DTU, eDTU versus vCore models. So DTU is just a measure of how many times a given simple query can be run. They don't disclose what that is, but it's going to be something like selecting a row via a primary key or something trivial like that. And that gives you a number. vCore is where a vCore is allocated to your DB. And if you go and try and math out the performance figures to work out which one's better or whatever. It always comes out the same. Like, we choose whichever model you want. They don't make any difference in terms of practical how the workloads work. Microsoft's really cagey on how a file system I/O works in a lot of these in Azure SQL database. And there was a guy, I can't remember his name, but there's a guy who had a really good blog where he would benchmark all the different Azure SQL database series, and every time they brought out a new version or did a new release, he'd sort of show where IOPS have been hobbled on one version versus another, and all that sort of stuff. So you can sort of see that it's a little bit like software architecture by marketing department, unfortunately. One really good example is, when you just compare S and P series, right? So if you on paper just said, oh, look, there's an S6 instance I can buy, and that's got 400 DTUs, and there's a P1 instance I can buy, it's got 125 DTUs, then therefore the S6 instance is going to be faster, which might be true for some very trivial things like selecting rows by primary keys. But the moment you start wanting to flog I/O on this database, so where you want to really start pushing, I don't know, let's go and add up all the invoices in a big table or something like that, where you're going to have a heap of sequential reads to go and produce some result the business wants, even though your DTU allocation on that P1 is a quarter of what it is on the S6, the P1 outperforms it by 10x. So you really need to look at what your workload is, and we know certainly from our internal application CloudLift that we use for doing those cloud assessments, it's always full of millions and millions of rows of telemetry from customer environments, and we learned that the hard way, keep pushing the barrel and buying this reasonably effective high DTU systems, and then suddenly tried it on a whim and realized that consistent throughput is much better on the P series. Microsoft do say that the storage latency is lower on the P series, but they don't really say that sequential reads and writes are phenomenally better. So that's something you need to look at. Just look, you don't have to buy, you're not buying these things for a year, right? So just benchmark a variety of different ones and see how it affects the application performance when you're doing your app dev. There's also some other cool features I'll let Dan talk about around read-only replicas and all that sort of stuff that comes bundled.
Yeah, so one of the issues that regularly you would hear is that somebody's got some reporting requirement, they're reading from a database quite heavily, and then it's affecting the overall database performance. So something not a lot of people know about this, but if you do a premium tier Azure SQL database, there's actually a read-only replica that you can target using the connection string, just a simple piece of information. I think you just go read-only equal true in the connection string, and that will then target your query to the read-only replica. So a case in point is, for example, we've got an automation platform where we scan all of our clients' infrastructures and what we know about them from our SQL databases on a very regular interval to monitor for costs and alert them if costs are getting out of control and that kind of thing. So if you look at that use case, we don't need to the data doesn't have to be 100% up to date. We just need to read data from the read-only replica. And so we point that to the read-only replica and thereby preserving the primary node for OLTP work without affecting it with that regular constant scanning and reading of the data. The other point I'd also make is that the Azure SQL database has got backup and you can't do a .back file backup and restores. It's all with imports and exports. Backups and restores are built into the platform itself. But if you just want a copy of the database, you do an export, which creates a backpack file, which essentially is just the data written to a file. And doing so will impact the performance of the database. So don't do that in the middle of the day. It's going to start writing the data, and it's going to be 100% CPU usage and disk usage until it's done, and so that will affect your primary workload. A way to get around that is you can clone the database to make another instance of it, and then export that. Is a bit of a way to get around that, but just be aware it's a bit of a gotcha. And the other thing to be aware of is if you use SQL Management Studio for importing those backup files, oftentimes the transactions that it needs to create in order to create those tables successfully can grow too large. So you might have to use PowerShell to tell it to write those indexes that it builds to storage and not in memory to get it to actually restore. Dave, do you want to go on to the Next slide.
Yeah, sure. So, and then I guess this is our last slide to go through really, and that's just making the point about Linux and its impact on Azure. It's been a number of years ago that someone said that more than 50% of the IaaS workloads or 50% of the workloads in Azure is Linux. It really, I get the sense that the writing's on the wall for Windows Server. We've just passed our certification as a company for another couple of advanced specializations with Microsoft, and that required a number of us have Linux certifications for that particular advanced spec as well. When the implication, when you're looking at app modernization, is that obviously everyone's familiar with the concept of hybrid use benefit, and you know that if you have an existing Windows license, then you can buy the virtual machine for the cost of the virtual machine without the OS license, which is also the price that virtual machine has when it's got Linux on it, because Linux obviously doesn't cost money. But it's not just that. You've now got the option to run app services Linux. So even if you're going down the full PaaS dream, you can get up to 50%. It's a pretty significant cost reduction. And when you start having a lot of app services, it's a big deal. Like a P1 V2, Windows is $252 a month, Linux is $123 a month, and you start running heaps of those, then it really adds up. I find it very telling that when you create a Gen 2 Azure Storage account, you're able to map that natively as an NFS drive to a Linux box, but there's no option to map that as an SMB share to a Windows server. Now, obviously, the requirement for that is probably to do with Databricks and all sorts of things at the back end that Microsoft use, but I still think it's an interesting thing to see, right? I think if you look at also SQL Server, the rumors are that, well, not rumors, it was in the press, but SQL Server on Linux outperforms SQL Server on Windows as well on the same hardware. We've moved all our internal applications across to App Service on Linux using .NET Core, and so these are code bases we've had running on Windows for quite a number of years and heavily invested in. Dan, you want to talk a little bit about that work that was involved in that?
Yeah, sure. So luckily with .NET Core, it's relatively easy to convert something to allow to run on a Linux app service. Some of the gotchas there is to watch out for some inconsistencies between the operating systems. For example, if you've got any code doing time zone manipulation or moving between time zones, those won't work if you just go from Windows to Linux. There's actually different time zone naming, so you have to sort of translate all that code over to use the time zones as it's specified in Linux world. Same with the app config or web config settings on the app services in order to make the app service run as a time zone. It's only recent that it can actually run in a non-UTC time zone, but the naming there is different. Some people did experience some issues with file system watches, any logic that uses file system watches on Linux. And it's also Linux is a little bit more finicky when it comes to port exhaustion. If you're opening connections and don't close them, Windows was a lot more forgiving. So you might have code that's been running fine forever, and you deploy it to Linux, and its response times goes up. And so watch those connections when they're getting opened and closed, and connection pooling happens. Sort of the top items that stand out to me in that side of things.
Yeah, I think in terms of our fleet of internal applications that we use to drive our managed services business, we've got everything pretty much running on Linux. We do have to keep keep a Windows app service around at a small scale in order to talk to Microsoft's backend systems for the CSP relationship we have with them. We've got to use some SDKs that they provide that are available only as Windows binaries. But that's probably the only thing we've seen that wasn't just a direct port. If you've got a .NET application, certainly if you're on .NET Core, you're going to have a pretty easy time making the jump across to Linux. And I think the cost savings, depending on how much work you have to put in, but if it's something that's going to scale out on big instances over a long period of time, I think the cost savings are probably justified in doing it. And that concludes our Prezzo today. So thank you all for coming. Just wanted to do a very brief shill at the end, if I could. We are hiring. We're always hiring, but we are looking for Azure engineers to work in our managed services business. It's sort of pretty varied and interesting work. It is, it's essentially a managed services business, but it's not like a stratified level 1, level 2, level 3 help desk. You sort of work to your capability. on a lot of different things for different customers. And then on the project side, in terms of doing assessments for customers and doing migrations as well, we're looking for consultants. So love to see a CV in email to david@codify.com. That would be great. Back to you, Mr. Toomey.
Wow, thank you, David and Dan. That was a really fantastic presentation. Very, very comprehensive. Lots of great tips in there. There's actually no questions in the chat. There's a couple of comments from Adam Stevenson. Hi, Adam. About agreeing with the whole idea of avoiding the ASEs, except for some very, very specific use cases. And I would say too, that would apply, of course, also to an ISE, which is an integration service environment, which is essentially an ASE for integration. And I agree, yeah, with especially now with Logic App Standard, where you can deploy anywhere you can deploy functions, and you can take use of private endpoints, and VNet integration is probably very few reasons now to go and pay that stamp duty. Question for me, when you were talking about SSIS and replacements, what's your thoughts about Azure Data Factory as a replacement for that, if you don't need all of the analytical capabilities of Synapse, for example?
I don't know, is that a question you should be answering? Yeah, I mean, sure. I'm constantly confused. Like, well, make no apologies. We're not an integration or data expert company. We're cloud platforms where we're at. But I'm constantly confused as to what components sit within the Synapse umbrella, because there's obviously huge chunks of Synapse that look awfully familiar to Data Factory and various other products as well. But we've used Data Factory before, to do a lot of sort of interesting heterogeneous integration scenarios. It depends. Like, some of the integration providers for ADF are a little bit unloved. If you've ever tried to get data out of Xero, for example, and you'll just get some random ODBC error from some third-party library somewhere in the bowels of ADF. You can sometimes get issues like that. It can be tricky doing REST JSON consumption down to SQL as well, depending on what sort of issues you have in the source API for pagination and those sorts of things, and whether it supports tokenization. So there are a couple of the issues we've seen in the past. But in principle, yes. In principle, yes. And like, it's the old joke. Adam can just block his ears, but yeah, Microsoft always gets it really good by version 3. So.
Yeah, that's what I was interested in hearing, actually, with your stories on the trench on regards to ADF and what you thought of it. And it sounds like some of the same problems we have with Logic Apps, where not all the connectors are necessarily quite as mature, and introduce some problems as well. So yeah,
I think there's probably a land rush there to have coverage of connectors, so that there's a very impressive catalog. But whether or not there's the bums on seats in Redmond to make sure that those things are regularly maintained is probably the question mark that I would have, and that we've seen in a few cases. But if you stick mainstream, like if you're pulling something out of HANA and shoving it in Salesforce or something, you're probably going to be fine, right?
Sure. So do we have any questions from the group? Feel free to come off mute now if you want to speak rather than write or type. Maybe that you just explained everything so well and so comprehensively that
or everyone's asleep. Will
you guys be able to make your slides available?
Of course. Yep.
That'd be awesome.
No worries at all. Uh-oh, Adam's typing something.
Yes.
Oh, no worries, mate.
Thanks.
Thanks for coming. Appreciate it. All right.
Yeah, that was an especially useful presentation. Lots of interesting things in there. So.
Yeah, well, grab that. Just grab that PDF that I stuck on the website and that blog post as well, because there's so many years of doing this have been distilled into that thing, and it will really guide how you talk to people internally. So yeah, hopefully you find it useful.
Right. So for the benefit of everyone is attending, I will post this recording. And speaking of the recording, since there aren't any questions, I might just end the recording now. So stop recording.